Okay, so this is another pedigree problem for us to solve. Let me just fix that typo right there. So again, step one of any pedigree problem is you're going to first look for references to anything like hemophilia or colorblindness anywhere in the text or anywhere in the key or anything that's saying that maybe it's X-linked. So sure enough, right here in the text, it's telling you that this is straight up an X-linked disease. And so now it's asking for what sort of inheritance pattern does it show. So step two to solving any pedigree problem is to look for any carriers. And it's not really telling me anything about carriers, so I kind of can skip that part. And then the next thing that you need to look for is it in every generation? Or is it skipping? So here we have generation 1, we have at least one affected person. So here we have generation 2, and again we have infected people here. And then for generation 3, again we're having affected people. So in every generation we have an affected person, at least one. So therefore this is for sure a dominant disease of some kind. Because it was in every generation, here, here, and here, we know that this is dominant. Sorry, it's for sure dominant. And because they told us right up front that this was X-linked, we can say that it's X-linked dominant. So the next question is asking us, what is the genotype of person 2? So because we're in X-linked land, person 2 is a male, so we know that he is XY. And if it's X-linked dominant, so let's just make up a letter, say A, he would have to have the lowercase allele because he does not have the disease. So this would be his genotype. And so let's look at person number 7. So again, this is X linkage, so we're going to do for a boy, this is XY. And because they have the disease, they would have to have the uppercase allele. And then so for person number 8, this one's going to be a little more complicated, right? So we know that she's XX. And let's go ahead and fill these in now for this whole family. So let's start with mom. She's going to be XX. And we already have dad as XY. So we have this female here. So we have number 9 at this point. So he's XY. And this one is also XY. And this one is XX. So for this boy to be normal, he has to have the normal uppercase A allele, and same for this guy, same uppercase allele. So we really want mom. So let's go ahead and draw out our Punnett square. So we have dad, whose genotype we already have, so he's XY. He's going to have that uppercase A disease allele. So these guys are wrong. Delete. Sorry about that. So because these males are unaffected, they would have the lowercase a's. And this female here, she has to have at least one uppercase A. Same with this female, she has to have at least one uppercase A. So we know, so let's go back to number 6, the number mom. Oh no, we're wanting person 8. Okay, so let's go back to mom. So she's XX. And we know that because mom is unaffected, she has to have 2 lowercase a's. Because if she had 1, she would have the disease because this one is a dominant disease. So we actually do know mom's genotype right up front. So for these boys, we know that the boys only have one option for their X chromosome from mom, So they are going to be XA, XA. So that lines up with what we're seeing here. But for the girls, they're going to have something different. So both girls are going to be XX. But now, half of them are going to get their X chromosome from dad. So this will be XA, and this will be XA. There's no other option for them. And so they will get their other allele from mom. So they will be lowercase a for each one. So then, therefore, the genotype for person 8 is going to be XA lowercase a, because that's the only option that we had from this one here. So that is how this X-linked dominant one is going to work.